हेलो। हाँ सर, आवाज आ रही है।
ओके। ज्यादा लोग ही नहीं आ रहे। ठीक है।
आपकी मर्जी सर, अब हम तो आ
कोई
गए।
नहीं। we'll definitely go for the meeting, don't worry.
यस सर, वी आर
Yes,
हियर।
sir.
Is my screen visible now?
Yes, sir.
यस सर।
Okay, so in the today's video we are going to discuss about the multiple integrals. Especially we will be
सर
focusing
शुड
on
सर
double.
शुड आई ड्रॉप अ रिमाइंडर ऑन व्हाट्सएप टू join the meeting?
Okay, we will wait for 5 minutes. I guess
Okay.
not everybody got the message because well I do have that in my college habit of just starting on the time.
Yes sir, either you can tell this CR to convey the message.
Well, I'm not on the CR's group, but let's wait for 5 minutes
Okay
because
sir.
Sir, we can inform them.
yeah, sure. Please inform them. Don't worry.
Okay, sir.
Okay.
Even if not many join, we know we are going to record this session, so at least they will have the video for this. I forgot to turn on the recording. I will just turn on the recording. Where is
Okay
that?
sir.
Okay, I guess recording is automatically started.
Yes sir.
So it's better. so I guess we should start with the meeting. So in class 11th and 12th, we started with single integrals. And in this case, we had a function. We had a function of one variable of one variable. Let's call that function as f of x is equal to some y. So this was our given function, and we wanted to calculate area under the curve, area under the curve y is equal to f of x, and some values between x is equal to a to x is equal to b. So what we had, so let's say these are our coordinate axes. We had a function moving like this. So y is equal to f of x, and we had 2 points. Let's call them as x is equal to a to x is equal to b. To calculate area, what we did, we divided this region into n parts. Maybe equal, maybe unequal, that doesn't matter. But we divided this region into some n parts. So x1 dot 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 till we got xn, xn minus 1 and xn as b. So x0 was a and xn as b. So we divided this region into n parts. Then we calculated area. We calculated area as a is equal to summation n going from 1 to n, or I should change the variable, k going from 1 to n, f of xk into delta xk, where delta xk is given by xk minus 1. So this was a rectangle. Notice that for any given value k, this was delta xk, and in that case, this was f of xk. So we're calculating area as this rectangles, area of this rectangles. We had some error involved in this pink area, but we said as n goes to infinity, the error was going to infinity or going to 0. So we are going to generalize this fact, and now assume we have a function of two variables, a function of two variables. Let's call that function as z is equal to f of xy. So I will draw the base region. So consider this is my base area. Now I'll calculate, and given some area, let's call that a in xy plane. In xy plane, then we calculate the volume bounded by this function z is equal to f of xy as height, and the area A as base area or as base as follows. as follows. So what we will do, we'll divide this region into n. Similarly, like the last time, we'll divide this region into n equal parts or n parts, not equal but different n parts. So we'll divide those regions into n parts. So something like this ones. So this was our area A, and let's call this as delta A. So we'll calculate volume as we will calculate volume as V is equal to summation k going from 1 to n f of x, I will say some xk yk at that point, into delta A, where my delta A is given by delta xk into delta yk. So that's the multiplication of these two area elements or these two linear elements. So let's say if my delta A is this one, and this pink area will be my delta xk, and this will be delta yk. So getting this pink area as my base area, and then I'm multiplying height as the function height. So I'm calculating volume covered by this rectangle as the base area and height as that f of xk. So I'm calculating the volume of that cuboid, and I will sum it over all these regions. So in calculation, what we will do to calculate that, we'll denote this as integral over a f of xy dx dy, and we will calculate it as some integral from limits of the x. So I'm calculating it as dy dx in this case. So limits for x going from a to b, and I'm having two functions in the xy plane. So this is y is equal to g1x and y is equal to g2x. So this function is my g2x, and this lower function is my g1x. So ping functions till here. So I'll calculate that area as integral a to b integral g1x to g2x f of xy dy dx. So I'll be calculating it as an iterative integral as two integral. So I will calculate this as twice. I will integrate this function twice. First with respect to y and then with respect to x. So while integrating with the inner function, we'll consider the other variables as constant. So in this case, I'll be considering y variable as constant. So let's directly move on to some examples. So consider this example where we are integrating integral 0 to 1, integral 0 to 2 x square plus 3xy square dy dx. So I'll just rewrite this integral first. So integral 0 to 1, integral 0 to 2 x square plus 3xy whole square dy dx. So notice that here the first integral is with respect to y. So while integrating this function, inner function with respect to y, we must treat x as a constant variable. So since x is a constant variable, I'll keep the outer limits as it is. So I'm integrating y square with respect to dy, but x is a constant because we are integrating with respect to y. So this will be x square y because it's something like integral k dy, whose integral is ky plus c. So I'm not writing plus c because we are going for the definite integrals. And then 3xy whole square, we are integrating with respect to y. So we will have x y cube in the limits 0 to 2 dx. We'll substitute the upper and lower limit as our regular integrals. So here, notice that integral was done with respect to y. So substitute y is equal to 2 as the upper limit. So we will have 2x square plus 8x minus, if I substitute y is equal to 0 as lower limit, I will have 0 plus 0 dx. That is, I will be having integral 0 to 1 2x square plus 8x dx. So now, to calculate the final integral, we need to integrate this integral with respect to x. Notice that this is our regular one order integral, one order definite integral. So we can evaluate this as integral of x square as x cubed by 3 plus integral of x as x square by 2. So it will be 4x square, both in the limits 0 to 1 and 0 to 1. So we will have, when I substitute the upper limit, I will have 2 by 3 plus 4. And when I substitute the lower limit, 0 plus 0. So therefore, I will be having 12 plus 2, 14 by 3 as my final answer. So how we are going to evaluate our integrals, double integrals? We are going to start from the inner integral first, whatever inner integral is in the given order. So if my inner integral is with respect to y, I will be integrating with respect to y, keeping x as a constant variable. I'll be putting variable limit. Notice that this can be a function of x, any function of x, and this also can be a function of x. So I'll be substituting those functions as upper and lower limit, and I will be continuing the calculation till I get the final answer. So since in some cases we may have functions of another variable as the limit, so let's see some example considering those facts. So again, we will rewrite the question. So integral 0 to pi, integral 0 to a into 1 minus cos theta 2 pi r square sin theta dr d theta. So this is integral 0 to pi. Again, we will be integrating the inner integral. Inner integral is with respect to r. So theta will be a constant variable. Notice that 2 pi is already a constant and sine theta is acting as a constant for the integration. So we are integrating 0 to a into 1 minus cos theta sine theta, not sine theta, r square dr, and then finally we will be integrating with respect to d theta. So to get the answer, integral 0 to pi, this constant is as it is, and this integral r square dr can be written as r cube by 3 in the limits 0 to a into 1 minus cos theta d theta. So we'll continue with the calculation. Integral 0 to pi 2 pi sine theta. So substituting the upper limit, I will have a cube, or I will also take that 1 by 3 common. So I'll write down 2 pi by 3 sine theta into a cube 1 minus cos theta the whole cube minus 0 d theta. So I'll take the constant outside the integrals, 2 pi by 3 integral 0 to pi, also this a cube. So we are having 1 minus cos theta whole cube sine theta d theta. Notice that we can change the variable here. You have two options. You can either go for beta gamma functions, or you can simply change the variable, because you can see sine theta d theta. So you know you can substitute for cos theta or some constant plus cos theta. So here, put 1 minus cos theta as t, which will give me, notice that if I differentiate this quantity, I will be getting positive sine theta d theta, because differentiation of cos theta is minus sine theta, but there was already a minus sign here, is equal to dt. And if I want to check the limits, when theta is equal to 0, cos theta will be 1. So this will be 1 minus 1 which is 0. And when theta is pi, cos theta will be -1. So -1 will give me the value 2. So using these changes, I can rewrite my integral as 2 pi by 3 a cube integral 0 to 2. This quantity is replaced by t power 3 and sine theta d theta is replaced by dt. So here we are having 2 pi by 3 a cube into t to the power 4 divided by 4 in the limits 0 to 2, which can be written as 2 pi by 3 a cube into 16 minus 0 divided by 4, which can be evaluated as 8 pi a cube divided by 3. So far we have covered the theory of double integration. So similarly, what we will do in the triple integration, similar to double integration, similar to double integration, we shall evaluate triple integration as iterative integral for 3 times. So we'll be having some triple integration over some volume and a function of 3 variables in some given order. So we will be evaluating that as integral over a to b dz, integral say f of f1z to f2z dy, and finally integral from g1xy to g2xy f of xyz dx. So here, like the previous case, we will be evaluating this inner integral first. And when we evaluate the inner integral, we'll have some integral a to b, integral f1z to f2z, and some function capital G of xy dy dz. So after substituting the upper limit and lower limit, we'll end up with a function g of 2 variables. In that case, x will be eliminated. So this function has to be a function of y and z, not x and y, so that x will be eliminated after the integration. Then when we evaluate this inner integral, again the function g, from function g, we'll get a new function of variable z, of new variable z, and we'll be evaluating that as our regular integration. So in this step, and we will get our answer. So in the triple integration, we'll calculate this integral at 3 times integration. The first inner integration will with respect to one variable, keeping other 2 variables as constant. The limits of the integration can be functions of other those 2 integrations. So if I am integrating with respect to x, the limits can be functions of y and z. Then after calculating and after substituting the lower and upper limit, I will be getting a function of those other 2 variables. Let's call that function as g of xy. Then we'll be evaluating that double integral like the previous case. So if we are integrating with respect to y, then z variable will be acting as a constant variable for that inner integral, and the limit can be functions of z. And finally, we will get a single integration which can be evaluated in our usual methods. So let's start with an example. So this was the classroom example, but quite good example. That's why I want to repeat this again. So integral I is equal to integral log of 2. Notice that but whenever I will say log, I mean I'm using log. Here for me is ln or log to the base e, not log to the base 10. Okay, so just keep this thing in the mind, because whenever I will see log, this is the thing that I will be using. Log to the base not 16, 10. Okay, so whenever you will use the calci, use this calculation or use this fact while calculating the values. So integral 0 to xy e to the power x plus y plus z dz dy dx. So I will keep the other two limits as it is. I will not harm them anything. And outer integrals as it is. I will be integrating now this function where my x and y variables are constant. So notice that this situation is something like if integral f of x dx is capital F of x plus c, then integral f of ax plus b dx is capital F of ax plus b divided by a plus c. So using this condition, we can rewrite this integral as, or we can evaluate this integral as e to the power x plus y plus z in the limits 0 to x plus y. Here, this a is 1 and b is a x plus y. So now substituting the upper and lower limit, we'll get, so this as it is. So if I substitute the upper limit, notice that the limits are with respect to z. So when I substitute the upper limit, I will have e to the power x plus y plus x plus y. And when I substitute the lower limit, I will be having x plus y plus 0 dy dx. So I can rewrite this integral as integral 0 to log 2 integral 0 to x e to the power 2 times x 2 times y minus e to the power x plus y dy dx. Now we are again at the two double integral situation. So we are integrating with respect to y first. So x will be acting as a constant variable. And again, remember this rule. So from using that facts, integration of e to the power 2x plus 2y with respect to y can be written down as integral 2x plus 2y to the power 2x plus 2y divided by 2. Note that this time a is 2 and b is 2x minus simply e to the power x plus y, because a is 1, b is x, and in the limits 0 to x dx. If I substitute the limits, if I substitute the limits, if I substitute the upper limit, I will be getting e to the power 4x by 2 minus e to the power 2x. E to the power 2x. If I substitute the lower limit, I will have e to the power 2x by 2 and plus e to the power x. Simply e to the power x. In the limit 0 to log 2 dx. So integral 0 to log 2. I'll just simplify this calculation by writing this as 2 by 3. Notice that this both the terms have e to the power 2x. So 1 plus half is 2 by 3, 3 by 2. So that's why I'm writing 3 by 2 e to the power 2x plus e to the power x dx. There are no limits here because we have not integrated the function yet. So now we will integrate the function. So when we integrate, we will get e to the power 4x divided by 8 minus 3 by 4 e to the power 4x plus e to the power x in the limit 0 to log 2. So when I substitute the limit, notice that we will get e to the power 4 log 2 by 8 minus 3 by 4. This was 2x. So e to the power 2 log 2 plus e to the power log 2 minus, if I substitute the lower limit, I will get everywhere 1, as e to the power 0 is 1. So these ones. So now uh, notice that 8 times log of b is equal to log of b to the power a, right? So using this fact, we can write down this as 16 by 8 minus 3 times 4 by 4 plus 2 minus 1 by 8 minus 3 by 4 plus 1. I'll just simplify the terms. So I will have 2 minus 3 plus 2, then minus 1 by 8 plus 3 by 4 plus 3 by 4 and minus 1. So we can cancel out certain terms, I guess. So notice that this is plus 4 and this is minus 4. So cancelling out those, we have 3 by 4 minus 1 by 8, which is 5 by 8. So like the previous case, we are evaluating these integrals at the iterative integrals. First, we are integrating with respect to one variable, keeping other two constant, and then we are integrating the other two variables as double integrals. In that case, the inner integral, while evaluating the inner integral, we are treating the other variable, in this case x, as constant, and then we are continuing the calculation till we get the one order integration. So when we get the one order integration, we were integrating like the usual class 12th method, integrating directly using those regular formulas and substituting the upper and lower limit and writing their differences. So consider one more example. It's a two order integral. I thought I did a degree 3 variable or triple integration, but okay. So I'll evaluate this integral. So given integration is minus 2 to 2 integral square root of 4 minus x square to square root of 4 minus x square 3 minus x dy dx. So notice that inner integration is with respect to y. So we are treating x as constant variable while taking the inner integration or while doing the inner integration. Notice that there is no term of y, so it will be simply y. So observe that here f of y is 3 minus x. So therefore, f of minus y is again the same because there is no term of y. So therefore, this 3 minus x is an even function for y. It is not even function for as a function of x, but it is an even function as a function of y. So we can write down this integral I as 2 times integral minus 2 to 2 integral 0 to square root of 4 minus x square and 3 minus x dy dx. So this can be evaluated as integral minus 2 to 2 3 minus x square into y in the limits 0 to square root of 4 minus x square dx. So this can be written as integral minus 2 to 2 3 minus x If I substitute the upper limit, I will have 4 minus x square. I will write down that as 2 square minus x square and minus 0 dx, or 2 times of minus 2 to 2, 3 minus x square root of 2 square minus x square dx. So we'll split this integral into two parts. To calculate this integral, I'll split this integral into two parts. Integral minus 2 to 2, 6 times square root of 2 square minus x square dx minus 2x times minus 2 to 2, not 2x times, x 2 times x into 2 square minus x square dx. So we'll call this integral as I1 and this integral as I2. So we'll start with I2 first because this is easier to evaluate. So consider I2 as integral minus 2 to 2 x into square root of 4 minus x square dx. So note that if my g of x is x into square root of 4 minus x square, then g of minus x is minus x into square root of 4 minus x square, which is minus of g of x. So therefore, g is an odd function. So what we can say about this odd function is that integral minus a to a g of x dx will always be 0. So thus I2 is 0 because it was an odd function. So now we can focus on our I1. So this is 6 times integral minus 2 to 2 square root of 2 square minus x square dx. So we'll continue for this as I. So I is equal to this quantity. So 6 times, remember the formula. This is integral of square root of a square minus x square dx, which can be calculated as x by 2 square root of 2 square minus x square plus a square by 2, that is 4 by 2 sine inverse of x by 2, and everything in the limit minus 2 to 2. Well, this was an even function also. You could have used that fact also to calculate this integral. But we'll go with our usual calculation. So 6 times, I'll substitute the upper limit first. So I will have 1 into 0 plus 2 times sine inverse of 1, that is pi by 2, minus, when I substitute the lower limit, I will be having minus 1 into 0 plus 2 times sine inverse of minus 1 as minus pi by 2. So this will be 6 times. This 2 and 2 will get cancelled. This 2 and 2 will get cancelled. So pi, this is 0, this is 0. So pi and minus pi, which is plus pi. So this is 12 times of pi. So I guess you are comfortable with the iterative integrals that we have done here. I guess I should add one more problem. I will just go through some integration first. So I have opened the PDF right now. I'm just searching a problem so that we can We can solve one more problem. Before ending this meeting. We don't want change of order. We simply want a regular integration. So I guess we can solve a problem which was asked in the ISC. So consider this problem. I is equal to integral 0 to 2a integral 0 to square root of 2ax minus x square xy dy dx. So notice that inner integral is with respect to y. So we will be treating x as a constant variable or constant function or constant variable while integrating. So outer integral is with as 0 to a, and integration with respect to y for this term is y square by 2 in the limits 0 to square root of 2ax minus x square dx. So this is integral 0 to 2a x times or x by 2 times. When I substitute the upper limit, I am having 2ax minus x square. When I substitute the lower limit, I am having 0 dx. So this is integral 0 to 2a. 2 will get cancelled. Ax square minus x cube by 2 dx. So the final integration is with respect to x. So integration with respect to x for first term will be ax cube by 3 in the limits 0 to 2a minus x power 4 by 4 again in the limits 0 to 2a. So when I substitute the values, I will have 8a power 4 divided by 3 minus 16a power 4 by 4. So this will be 8a power 4. This will be 8. So this will be 8 again. So 8a power 4 minus 2a power 4, which is 6a power 4 by 3. So this will be 2a power 4 divided by 3. So I guess that's all for today's meeting. If you have any questions, we can definitely ask. You can definitely ask in the chat. So I'll go to the meeting so that if you have any questions, any concern, you can ask in the chat. So we'll wait for 2 minutes, and if no one is having any question, we will end this meeting. So I guess since no one is having any question, we will end this meeting. So thank you for your attention. We'll meet in the classroom. Thank you.